Let me show you a useful trick that you might not be aware of when it comes to integration by substitution. So suppose you're asked to integrate this. So our normal routine would be to make this as u. So our normal routine, which is set u equals this thing here, then du equals this thing here, then dx equals this thing here. So our normal routine would be to put this back into the dx here. And then our normal routine would be to put the u into this thing here. So following our normal routine, that would take us from this to this. So when you put it back into here, you see you've got this square root lingering around here. Because hang on, let's start again. So when given this here, our normal routine would to make u equal this, and then du equals this, and then dx equals this. So our normal routine would be to put this back into here. But the thing is, when you put this back into here, you've got this annoying square root of x lingering around. So when you put this back, when you put this back into here, that will then give you this. That will then give you this. But then you've got this annoying square root. There's no way of getting rid of this square root here. So the trick here is that, hang on, let's start again. So when you're asked to integrate this, u equals this thing here, follow through the whole process, dx equals this thing here. But the trick is that before you put this back into here, look back to here and replace this square root here. So look back to this and then rearrange this. Add square root of x to both sides. That will then give you this, and then take away u. So square root of x equals 1 minus u. So before you put this back into here, replace the square root with this. Replace the square root with this. Okay, so really you should put this back. Bracket 1 minus u, and then du here. So rather than putting this back into here, we should put this back into here. Okay, so that's really the trick. So rather than putting the square root back into there, recycle this, use this, and replace the square root. So that will then take you to here. Hang on. So hang on. Before you put this back into here, So before you put this back into here, hang on. So before you put that back into there, so before you put the minus 2 square root du back into there, replace the square root with 1 minus u. So put this into here. That will then give you this. Okay. Now multiply this out. So that will then give you this. Okay. Don't forget you switch these two around. Well, tidy this up. It will then give you this. So now we can put this into our so starting again. Hang on. So originally we were given this. So now we would then put this into this dx here. Okay. So that would then that would then give us this. Okay. So overall it would give us this. And then now tidy it up. So this gets multiplied to the top. That will then give you this. And then break the fraction up. So break the fraction up. So that will then give you this. And then now you integrate it. So when you integrate this, it will give you 2u. And remember the integral of 1 over u is really the natural log of the absolute value of u. And we've done this in the past. Okay, so if you integrate this, it will give you this. We've done this in the past, so you might have to refer back to it. Well, integrate this whole thing here, it will then give you this plus a constant. Okay, so it will be an absolute value of u here, and then substitute the u back in. That will then give you this. So it's really the absolute value here of this thing here. Okay, so your overall answer is this.